right. All right, so question 2. Which one is quantitative? I put the 3 most common brands of car. Except I don't know about that one.
Isn't quantitative like numbers?
Oh, good call. So number of people in a randomly selected camp. That would be quantitative. I was doing it opposite. And then the 3 most common brands of cars, you could find that out quantitatively, but is that a qualitative?
No, because I think it's talking about the brands, and the brands is a category.
Qualitative. Okay, so just the top one then?
Yeah.
All right. And then question 3, I put it's an observational study because the students had no control over the price of the cereals.
That's what I got.
4, it is not possible to determine without a full data set.
That's what I got.
Okay. 5, I put 95.0.
I got 2.5%.
Which one? What did you get?
2.5. What percentage of students will complete the exam in under 50 minutes? 50 minutes is 2 standard deviations less, right?
Right.
And so under it would be a left-tailed one.
Oh, and that's going to be both tails, right?
95 would be both tails, so each tail would be 2.5.
Oh, okay.
85% falls in the middle.
I see what you're saying. Okay, that makes sense. So I was thinking that the 95 was on the end, but you're right, the 95 is in the middle, so we're looking at the tails.
Yeah.
Okay. I concur with that. I think that's makes sense. Question 6, I put 146.8.
Okay.
And I struggled with that one. I had to look up some of the original reading for that. Question 7, I put we cannot be sure until we examine the data. But let me see.
I got skewed right. I actually looked that one up, and it says that if your distribution is right skewed and your number of samples is lower than 30,
then it'll be right skewed. Okay. Yeah. I was debating between those two. So right skewed. I'm okay with that.
Okay.
Yeah. Okay. Question 8, I put 3.536.
I got 0.5.
0.5.
So n is 20, z-score. So wouldn't it be 850 minus 850.44, 8550 minus 8544 divided by
8540 minus
12.
854. Okay, what did you say? 8540 minus
8550 minus 8544 divided by 12.
So 0.5. And that would be our z-score. Okay, yeah.
Isn't that what the z-score formula is?
Mm-hmm. Yeah. Okay. I found a different z-score formula that had something else going on earlier, but yeah.
Okay. 9, I got 0.630.
A simple random sample of, and it was... Okay, so how do you compute that one? Because that one you have to use the z-score from the last one, right?
No, because you have a different amount of gallons.
Oh, so now we're using the 50.
So what is the probability that the mean capacity...
Oh.
Hi, Larry.
Hi, Larry.
Mean capacity of these 50 tanks will be greater than... So you do 850, 8540 minus 8544 divided by 12, and then you shade, using the applet, everything to the right of it.
Okay.
So you gotta get the z-score first, so it would be 8544 minus 8540 equals that, divided by 12. No, whoops, I did that back. 8540 minus
Lori,
8
can you hear us, Lori?
divided by...
Oh. Mm-mm.
She can't hear us?
She can hear us. We can't hear her.
Oh, okay. So negative 0.33333 is the z-score that I got. Is that what you got?
Yeah, negative
Can you hear me now?
0.3333. Yes.
Hey.
Oh, I think I figured out how to do it. What number are you on?
We are. Oh, which question are we on? Question 9.
9.
What did you get for question 9?
I got 0.991.
That's not what I got.
That's what I got.
Am I doing something wrong?
I don't know. I was using.
I did the I just did the, I can't remember. I did this like at midnight last night.
I'm like, which thing did I use for that one?
I thought I did the one test thing.
The one sample t-test, or
I thought that's what I did.
maybe it was the z-test.
And what did you get for? Did you get 2.236 for 8 for the z? A number 8.
For the z on number 8?
The problem with using a t-test is that it doesn't know the standard deviation.
They did it on my.
Yeah.
What did you get for 8 then?
0.5.
You got 0.5?
Yeah, so from what I understand, the z formula is your sample mean minus your average mean, or whatever that's called, divided by your standard deviation, and that's how you get z. Is that correct?
That is, but I'm wondering where the 20 tanks factors into it.
The n minus 1.
Does that alter it somehow?
It possibly could. I mean, let's find it on the in the book. Test.
I have to move my phone.
Kind of look and see. I should have wrote on my workout.
You know, so I'm like, I wish I would have written down what I was doing, because it's gone now. Okay, a trigger.
Well, and I can't open. I have to open up the SPSS on a different one because on my Mac, my screen's so big it takes the whole screen and it won't let me click onto the iLearn. So I have to have 2 computers to do my schoolwork. That's kind of frustrating.
That is frustrating. So I don't know how I missed this, but the formula is sample mean minus statistics divided by sigma divided by square root of n.
Okay, I think that's the one I was using earlier.
Okay, and
That's the one I was using.
that would definitely give us a different answer and probably make it more right if we use the right answer.
Okay, so say that equation again.
So it's the same thing that we had, just you add the times the square root of
n. That's where you use the n equals 20.
So 0.5 times point times divided by 12 is that times square root of 20. So what did you guys get for the z?
I got 2.236.
Okay, that is, yeah, that's what I got the second time.
Okay, and then
40 minus 8544.
And then with that, that's how I got the 0.991 for 9.
and that's what I have for 9 as well.
You got what?
0.991.
Okay, that looks like it'll make sense. What'd you get for your z-score?
On which one?
9.
I don't know.
How did you find it on the applet then?
Oh, I'm sure I had a z-score at one point.
Oh, okay. 0.991 is what I got.
Well, I think
I got negative 0.23, I mean negative 2.357 is my z-score. Okay, now that we're all on the same page there, did we change one earlier that we probably shouldn't have?
I don't think so.
Oh, no,
It was the quantitative qualitative one, which you were totally right on that one because I was reading it wrong.
Okay.
So we can go back up to those real quick. So for Lori, we put on question 2, we put the number of people in a randomly selected classroom on campus.
I got that.
Question 3, an observational study because the students have no control over the price of the cereals.
So, oh, you put an observational study?
Uh-huh.
I put the experiment because the students had control over which sampling method they used. You put that there was no control over the price or the cereal?
There was no control over the price of the cereals.
Yeah, and I agree with that one.
Because an experiment,
Okay.
You're altering the outcomes, right?
Okay.
That's what my thought was. Question 4, it's not possible to determine.
Right, that's what I put.
Oh, question 5, that's when we did change to 2.5%.
I got 0.3.
0.3.
You put 2.5?
Yeah, we were using because it says use the 68, 95, 99.7 rule. And so if our mean is 70 and we go 2 standard deviations below that, then that'll be that 95% rule. So the left and right wings of that would be 5%. So we just take the lower percent. Does that make any sense? Divide that by 2.
Okay.
And just take the right wing.
Okay.
Question 6, 146.8.
I got 146.773.
Yeah,
So, and then it just says to use 1 decimal point. So round up to 146.8.
Okay. Sorry.
Oh, you're fine. And 7, we put skewed right.
Mm-hmm. Yeah. Sorry.
And then that brings us to, we already did question 8 and 9 together. So question 10, I put the significance level is the probability of a type 1 error.
That's what I put.
Tanner, do you concur?
Yeah, I put the last one, but I didn't look it up at all, so yeah. I think you're right.
I think the last one, the significance level is the type 1 error, the p-value is the probability of obtaining a test statistic.
Okay, I always got those confused, so I trust you.
Well, I'm not sure it's a good idea. But that's what. All right, question 11, I put we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
That's what I put. And I also put C, approximately 95% of all 95% confidence intervals.
Yeah,
I
guess that is true. That is a true concept as well.
Yeah, I put both those as well.
Okay.
Okay, good catch. Question 12, I put yes, the distribution of sample means is normal because the data are normal.
I didn't put anything.
I put C. No, the distribution of sample means is not normally because the sample size is small.
Sample size.
Okay.
So 95%. Wait. One studies involves a random sample of 16 blue whales. Researchers want to create 95%.
I believe they have to have at least 30, and there's only 16.
Yeah, that would be a Z test. So the requirements aren't met because there's not enough random samples. I agree.
Okay, so the third one.
Yeah.
Okay.
This distribution of sample means is not normal because the sample size is small.
But isn't the distribution of means normal if the... Because that's what I was thinking. Because like with the whole concept of if your data are right skewed, your sample means are going to be right skewed. If your
But
data are normal,
I
your
think
means
it goes back to the requirements of a confidence interval.
true.
Right.
Very good. Okay.
Requirements of a confidence interval is X must be normally distributed, a simple random sample is drawn from the population, and sigma is known. It doesn't say anything about, the requirements of normality is satisfied if the raw data are normally distributed or the sample size is large. So, I think she is right. I think it is met because it is normally distributed. From the book it says or.
Yeah.
So I think you're right, Haley.
Okay.
You think it's A?
Yeah.
That's kind of... Okay. 13. I put 0.019.
That's what I got.
0, what was it?
0.019.
I got 0.039. So
0.039. Rates of return. So that one, I think I still have it open. Because that's a one sample t-test, right?
mm-hmm.
And so you enter your data into the one sample t-test. And then you change your null hypothesis to 0.95 because their rates of return is 0.95. And then where you want the less than. Is yours clicked to less than?
Okay. I'll go with it.
Because you had 0.038. Does that sound right?
0.039.
Okay, so that would be if it's not equal to, and we want that he's getting less of a rate return.
Okay.
Does that make sense?
Yeah.
So it's just changing that alternate hypothesis on that screen. Okay, a financial economist, blah, blah. So 14, I put dependent sampling. He needs to select couples for his sample, so whether a particular wife is included depends on her husband being included.
That's what I put.
Okay. 15, 0.096.
Yep.
Okay. 16, I put no because the p-value is greater than the level of significance.
Yeah, that's what I put.
Okay, 17, yes, the distribution of means difference. Wait, yes, the distribution of means differences is normal because the data have been determined to be normal.
I put C.
I put C.
Okay.
No, the distribution is not normal because
Yeah, no, the distribution of means differences is not normal because the sample size is not large enough.
Okay.
Does that go back to the requirements for using a desired confidence level? 16 on my slide.
I don't know though. I might agree with you guys on that one because it doesn't say anything about them being normally distributed. It just says the QQ plot has a straight line. But if you only have, right?
The fact that it forms a straight line says that it is normally distributed.
Right, but if you only had 2 points on your straight line, it's always going to be a straight line.
But it's still normally distributed.
Yeah. It's true.
I mean, and these aren't 2 points, these are 10 points.
That's true.
That's why I chose it, was because it's 10 point.
But I think it goes back to the same problem we had earlier, and I think it is normally distributed because it says the requirement of normality is satisfied if the raw data are normally distributed or the sample size is large. And I think that the fact that it forms a straight line shows that it is normally distributed.
So, yeah. I can see either answer on that one, honestly.
Too bad we can't put both.
I know. Yes and no. Give us more information.
Does this have...
So, whichever one you guys want to put on that one.
So this is for a 2-sample t-test, right?
Which one?
The one that we just did.
117?
Yeah. Two.
Paired data, right?
Yeah, because it would be, they're assessing the same home.
And is it a hypothesis test? Confidence interval. Confidence interval.
Hypothesis, well, let's see.
So the requirements for creating a confidence interval for the difference of means are the same as the requirements of the hypothesis. We must assume that a simple random sample is drawn and the mean of the differences is normally distributed. That's it. It doesn't say anything about size. So I think we are good.
Okay.
I'm going to go with B.
Okay. So 18, I put the third one, the null of the, so the differences equals 0, and the alternate, the differences don't equal 0.
I put the first one, but I couldn't remember off the top of my head.
Oh, that might, that might work.
What is this again? Oh, so it's where we just were, right? And it is a confidence interval, so what's the hypothesis? It doesn't say. Why doesn't it just tell me?
I think we've seen,
Where?
where'd Lori go?
Oh, is she gone?
Yeah, she's trying to video call me, but that won't work.
I'm going to invite her again.
Sure. The only reason I chose the third one is because in the previous question we're talking about differences.
Which makes it a paired mean, correct? So what is the... Why can't it find the null? Okay, so it says... So I guess the null and the alternative are... Yeah. So the mean of the differences is equal to 0. And the mean of the difference is not equal to 0. So yeah, you were right, it's C. Are you there?
Mm-hmm. Just thinking. All right.
I was like, man, I'm in this meeting by myself.
What?
I thought you got kicked out too.
No, you're just talking to yourself, Tanner.
That's what I thought.
All right, so question 19, I put 95% of all the 95% confidence intervals actually contain the true mean.
I hate those questions, but that's the same one I got.
Hey, but that's a good sign.
We can both get it wrong together.
Yeah. Question 20, I put 34.
I put 50.
Okay. Are you there?
We're here. You're back.
Sorry. For some reason, my computer just went.
That's all right. So for 19, we put 95% of the 95% confidence intervals contain true mean.
Yeah, that's what I got.
And 20, I put 34, and Tanner put 50. Did you put either of those numbers?
No, I put 50.
All right.
Wouldn't it be 0.2? What's the p at? Oh, it'd be n times 0.2 equals 10. So it'd be 10 divided by 0.2.
10 divided by 0.2.
You know I'm getting those numbers.
I'm good with 50. Let's go with it. I just opened up the applet and just started entering numbers until it said the requirements were met. So I'm not sure that's like statistically correct way to answer that question.
You guys are
We'll
getting
go with your answer.
tired. You just want to get the semester over with.
All right. So 21, I put
So
no.
what did you decide on?
50.
50. 21, I put no. 40 times 0.233 is less than 10, so the conditions are not satisfied.
That's what I got.
That's what I got.
22, I put 51.2% of the gametes in the sample have the male chromosome.
That's what I got.
Is that C?
D.
Or you put D? I got C.
Well, she's not testing. P-hat is for the test, and she's not testing all of the dog gametes. She's just testing the ones in the sample.
Okay, that makes sense too. Okay, thank you.
Yep.
Okay.
23.1.
You got what?
I got 0.1.
All right, sounds good. Because I was debating, because I got 0.996, but it says to round to 1 decimal. So.
Okay, yeah, so I think I got 2.
Okay. 24, I got 0.182.
Okay.
I got B.
You got
which
B?
one?
I got B 0.091.
See, the thing with
That
that
would
is
be
you have to
one-sided.
double it because it's two-sided.
I'm not even sure how I find these. Oh, yeah.
Are you there? Oh.
Because it says the area to the right of the Z is 0.91. We also need the area to the left.
Yeah, because the alternative is a not equals to, so it's a two-tailed test.
Yeah.
Okay.
And they tell us that one tail is 0.091.
Yeah. Okay.
So it's 0.182.
Right.
Yeah.
Okay. Thank you.
25, I put the fourth one down, so NP greater than equal to 10 and N times 1 minus P greater than equal to 10.
I put the first one.
I put A too.
Okay.
Because if it's X bar, that is meaning it's a Z test, right?
Yes.
Okay, so.
Because in proportions, they use P
Oh,
and P-hat.
true. Okay. So A. 26, I put the last one, no.
I
I put D. No, because the sample size for the women is too small. Is that what you put, Haley?
Wait, hold on. So 25, I think, is trying to trick us. I think it's any N will do.
No, I don't think
It
so.
says, it is known that the distribution of fertility levels of Cocker Spaniels is normal.
Oh, that's true. And that goes back to that whole concept of if the distribution is normal.
Right. So I think it's any N will do.
I do remember wondering about that one.
I remember they asked this exact question earlier, and I remember being so frustrated because I got it wrong. And I think this is why I got it wrong.
Which quiz was it in?
Yeah.
Do you remember?
I don't remember if it was a quiz or a homework or a test.
Oh.
I think it was a test that I went over with her.
Oh, okay. I'm down with that. Can you tell it's the end of the semester and I'm just like, ah, whatever. Good. Okay. So 26, no, because the N times 1 P-hat is less than 10.
That's what I got.
Okay. 27,
What was it?
U1 is not
I'm
equal
sorry.
U2.
And 26, what was it?
The last one. So no, because
Okay.
it's less than.
Thank you. Sorry.
Oh, you're fine. And 27, U1 does not equal U2.
After 6 months. I
put
thought it was
B.
the first one.
D
I
or
put
B? Each participant received another
I did
score.
have C, if any consolation. I had C first and then I erased it. I don't know.
I think
You know,
it would be.
they do mention difference in the question, so it could very much be D or B.
Yeah, I think it's B, and that's the same kind of question that we had earlier that we were discussing.
Uh-huh.
And we decided on B.
Okay. So the difference does not equal 0. All right, so 28, his actual weight loss. This one I'm like not even sure how to calculate this. I put his actual weight loss was 5.5 pounds higher than he predicted. I'm
Yes,
not sure what the residual means.
That's what I got.
that's what I got.
And yeah, the residual is in the last assignment, and that was the definition of it.
Okay.
If it's positive residual, then it was higher. If it was negative, then it was lower.
Yeah. Okay. Now that you mention it, I do remember that. All I could think about was like leftovers in like a pot. I'm like, if you have them there, I'm like residual. All right. So 29. Oh, I didn't answer this question. For the study in question 3, the B1 of the regression line was 5 pounds. Interpret this statistic.
C.
I got C also.
C?
Mm-hmm. What did you get?
I think that's the one I would choose. So, when creating a scatter plot, blah blah, I put all of them except the first one. But,
I also left out the observations are independent
okay.
because
I left out A and C.
A and C. Okay. Yeah. Okay. So B, C, and D. Oh wait, no. A, B, C. I can't do my alphabet. B, D, and E. I don't know. All right. 31, 0.780.
I got 0.
That's exactly what I got.
0.806.
0.806.
So what did you get?
So 0.780.
Great.
And I used the twos. No, what did I use?
So we have to use the linear regression, right?
Oh, yes. But where did I? That's weird. I hid my linear regression equation. Oh, it's probably on linear regression. Ta-da!
Linear regression. Need to open up. Stupid flight.
I wasn't sure which one to put where. So I put the 90 days in the X variable and the 14 days in the Y variable. Is that what you did? What's the question? The correlation coefficient. And that actually is computed right there. But you can compute the correlation coefficient by just putting the, well, if you're in Excel, equals correlation, or the CORREL or whatever, and highlighting your two columns. But
Right, so how do we get different answers? Hold on, let me plug these in. Copy.
That's still 31, right?
yeah.
Okay.
I got R is 0.780.
Perfect.
Why didn't I get that the first time?
Who knows?
Okay.
It just happens. Sometimes I think my calculator has its own mind.
32, I put linear with a fairly strong positive association.
Okay.
Yes, that's what I got.
33, I put 115.640.
What?
115.640, is that correct?
Yes. And
That's
then 0.627.
That's it.
So,
Wait,
Tanner, do you still have, are you using Excel or SPSS?
Excel.
Awesome, because I love Excel.
Yes,
So, did you just enter into the linear regression tab your 90 and 14 days into your X and Y?
Yeah.
So if you go over to H13
Mm-hmm.
and H14, it should give you your B0 and B1.
That's what I know. That's what's throwing me off, because I got something different than you guys. What did
Really?
you get?
But you still have the correlation coefficient up the R as 0.780?
Yeah.
This just
Yeah,
proves
I got negative 17.087.
Weird.
Hmm.
And
I wonder if it has anything to do with the order that you put your X and Y's in. Like, did you put your 14 days in your explanatory variable or your response variable?
no explanatory.
You put it in the, because I put 90 days in your explanatory and 14 days in response.
Really? Why did you do that?
Because later on they talk about trying to predict your 14-day cost based on what your 90-day one was originally. So in order to do that, you're going to have to look at a 90-day to estimate your 14. So
Oh, it says it
90
right
days.
there. Filling the missing variables in the equation in the linear used to predict the price that took us 14 days before. Based on 90 days before. Okay, so let me do that.
Okay.
So you're using Excel?
Uh-huh.
Okay.
I use
Yep.
SPSS for the tests because I have to. I try to anyway. Did
Yeah,
that change?
hold on, I'm still doing it. I think it's so stupid that they make us use SPSS on the test. Okay, 115.640.
Yes.
What do you guys got?
Yep. And
Okay.
0.627 for your B1, which is in cell H14.
Yep, I don't know how I was so far off. I don't know what I was doing.
Okay. All right.
And that would change my Y. What do you get for Y?
So the Y in 34, I got 240, but I rounded up to 241. Yes. What did you get, Laurie?
Wait, you round to one decimal place?
Well, I got 240.97.
I got 241.0.
Okay, so 241.
So you rounded up to 241. Okay. 35, I put 0.518 for the lower bound.
Okay.
Yes.
And 0.735 for the upper bound.
Yes.
Question 36, I put the null of lowercase b1 equals 0 and the alternate of lowercase b1 does not equal 0.
I put C.
I feel like it's trying to trick us.
Yes, that's exactly, yes, I think that's what they're trying to do. And that's why I switched it because, well, it can't be A or B because the B's aren't lowercase like that. They have to be upper.
Wait, why do they have to be upper?
So that's the sigma.
But I think that in linear regressions, they are lowercase b's, aren't they?
That's not in the lesson, because that's where I looked to determine. Because in the simple linear regression equation, it's lowercase b's.
Right.
But where's the, maybe it changes when you look at your null hypothesis. Let me see if I can find a null.
Oh, it is uppercase.
Okay. So in the equation they're lowercase, but if you're using it in a hypothesis, it's the upper.
That is stupid. I can't believe they do. So did you do the B naught or the B1?
The B naught.
Oh, the slope. So the slope is B1.
Right.
So it
Because
would be.
the intercept is B0. So D, that's what I put.
That's what I put.
D.
Yeah.
Mm-hmm. Change it to that. 37, I put 11.510 for my
Okay.
T. And
Okay.
for my p-value, I just put 0.000.
That's what I got.
I got 11.509
Yeah.
for the T.
Well, 509.
I did
I don't
round
know what somehow I rounded.
I
Because
just
you're-
right from the page and it says 11.510.
Yeah. Okay. Yeah, mine. Yep, you're right. Right on the page. All right, so 38, I put that we reject the null. So option 3, because there is sufficient evidence to suggest the slope of the true linear regression line does not equal 0.
That's what I got.
Okay. Oh, yay. 39. I put B. Anyone else have a thought?
I do too.
I put B. Good job. 40.
Okay. 40, I put A.
A.
Okay.
41, I put F.
F.
42, I put G.
G.
I put D.
No. Bad, Lori.
I put D. Independent sample t-test.
I put G because.
Because it's a yes or no answer. You're not having any numbers involved. So it's going to be a proportion.
Yeah, we're on the same page.
That's why I put 40 or G for 42.
Okay.
And then 43, I put I.
I put I.
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 I. Okay. We're done.
Hey, I'm submitting that.
Yay.
Oh, we got woohoo. 100%.
Good work, team.
Yay.
Now we're ready
But
for the
that
final.
one's over.
And I can't tell. It says for next week that there's a group meeting. But it doesn't look like there's a quiz, so I don't know if that's just for something else or what. But I can't access it for another 4 days. So, just in case we do.
Heard we heard from Celiana she's gonna get that assignment done?
She said she was going to email something to us, and she wanted us to look over it and email her back. I have not seen any emails from her.
Yeah, I haven't either.
Maybe we should shoot her a message just to remind her.
So, well, I don't know what she's doing. Maybe it's morning time over her there right now. I don't know. But we can message her. I'm also, I'm meeting with her at 9 o'clock in the morning.
You're the best, Haley.
So, to review this again. So I can ask her, but she said that it was no big deal and she was going to email us something. So I'll just double check with her and let you guys know for sure what I find out from her in the morning.
Okay.
Okay.
And I don't remember exactly what we decided on 8 and 9. Do you mind repeating that?
For the
Number
quiz that
number
we did,
9. Yeah, with the gallons.
8 we put 2.236
Okay.
and 9 we put 0.991.
Okay. I just wanted to make sure that's what I had.
Okay.
When you talked to her yesterday, did she say that she had started on it or anything, or did she need help, or?
No, she said she didn't need any help and that she'd just email it to us and and we could look over it.
Okay.
But like I said, I haven't seen an email, so I'll just let me just double check. Sometimes I don't check my email enough. But you guys haven't seen an email from her either.
No.
Okay.
I get it on my phone.
I was just a little bit. I hope she knows that she can ask for help if she does need it.
Okay. Yeah, I don't see anything from her. So I'll talk to her. I'll review the group quiz with her in the morning, and then I'll just kind of talk to her about what she needs from us and stuff. 'Cause she's awfully shy. So, but yeah. If for some reason she does decide she needs help, is it all right if I try to give you guys a call tomorrow evening to
Yeah.
kind of check you guys
Yeah.
got it?
Yeah, I should. Tomorrow evening I should be fine, but I will be busy every day from here to the end of the semester.
Okay. All right. So I'll give a chat with her, and then I'll just, if she's okay and is set to email us the document, then I'll just send you guys a message. If we need to actually talk about it, I'll send you guys a message just saying that we'll do a meeting tomorrow evening. Does that make sense?
Yeah, that sounds good, and I'll just check. And Tanner,
Okay.
how are things with the PowerPoint? Do you need
I
anything?
haven't started them, no. I've been kind of busy with other things, but I mean, PowerPoints are definitely not a problem for me.
Okay,
I could whip it out in like 30 minutes.
Well, I
awesome.
think, especially if because you have the document I emailed you, right? For the
Well,
design.
the one you wanted me
down.
to, yeah. Did we make any changes to that final submission?
Just some grammar changes that Laurie found. So I can email you the most current one, because I think if you have all of those papers that we've assignment or it's time for me to go to bed. All those the papers that we've submitted, I don't know much about the PowerPoint because I haven't looked at the assignment, but if you just paste all that information on there, isn't that pretty much what we need to do for the presentation?
It says we have design the study, collect the data, describe the data, make inference, take action, and that's it. So pretty much everything that we've done, I just need to paste it onto a slideshow.
Okay. So yeah, I will email you the actual copy that I submitted, just so that you have exactly what we submitted.
Okay. It's kind of funny to me that we don't need to like voice over or anything like that.
Yeah.
But I'm okay with that. Okay. Well, good work, guys.
Okay.
Yes,
All right.
thank
I
you.
will be in touch tomorrow via text or message to let you guys know about sailing on.
Thank you for meeting tonight. I appreciate it.
All right. Talk to you guys later.
Okay, bye.
Bye.